Alright, a couple of questions have been posed about my tailstock boring head arrangement here. The first one was, how do you get this level? And you put this bar in there. Now obviously you can see this isn't level here. One thing you got to do is lock this quill because there's some slop in it. So that takes that out of there. What I've got is an indicator on my compound. I'll put it on this bar here. And I run the cross slide back and forth. And you can see as I'm winding it in here, it's climbing. So that means this end is high. And there you go, that's level. Smack this in. Okay. The second question was, how come the taper's not going to spin? And that's easy. This is just like any other taper. For example, a taper shank drill. This can go in the tailstock and it won't twist, hopefully, as you're drilling, which is an enormous amount of torque. But if you put a center in here, and I haven't made one yet, but assuming that's your 3/4 inch center, the only torque, the twisting torque that's going to be on this, if this is a live center, is the ball bearing, and if it's a dead center like this, it'll just be the friction between the end of the center and the work, which is way less than what goes on here with this taper being locked in here. So hope that answers a couple of questions about why this works. Once you get this level, then when you offset, it's going to go only in this plane. It's not going to have any vertical component to it, which will keep you on the center line, or actually keep the work level to the bed. So that's a scoop on that. Okay, what I've got here is a piece of alloy steel. It's 3 inches long. What I'm going to do with this is I'm going to turn a 60-degree point on the end of this to be a dead center for that boring head thing that I just made. And then what I'm going to do is I'm going to case harden it. So that should be kind of interesting too. I'm going to set this up in the lathe, nothing fancy, and turn the 60-degree point on the end. Okay, first thing I'm going to do here is just face this thing off. Okay, and like everybody knows, I like putting centers in the end of things just in case we need to use it for something else. So we'll just put one in this. Alright. Yeah, I guess you can see that. It's way up there near the ceiling, so I can't see the viewfinder too well. And also put a little chamfer on this thing too, just to make it workmanlike. Okay. And you know, this doesn't really have to be accurate because you're going to use the boring head to center things up, so alright, I'm going to set up the compound for a 30-degree angle, which will give me 60 included. Hang on. Okay, so my my compound is not labeled right with degrees here. So the way I got my angle was, I took this 1, 2, 3 block and I sandwiched it in here. And what that does is it makes it square to this cross slide, the face of this cross slide. Then I took a 30-degree angle block and I slid it in here and I turned the compound until they were lined up. So now that's a 30-degree angle on the compound, which will give me a 60-degree included angle on the workpiece. Alright, here we go. Alright, I got the acetylene heat wrench out, and I'm going to spark this baby. Oh, nice. Man, I haven't used this torch in a long time. I think I'm running out of oxygen. So the bottom line is you heat this thing up to cherry red. I think we're going to need a little more juice there. I'm only doing the tip here. There we go, now it's getting red. Okay, and then you dunk it in there. Woo! Glad I got the fan going. This stuff stinks. So what this is doing is basically adding carbon to the steel to make it harder. Okay, and once this gets bright red again, I'm going to dunk it in some used motor oil. We're almost there. Called case hardening. And the longer you do this, the deeper that case hardening will be. Okay, that looks pretty good. Pretty good, but the file will tell the tale here. As soon as this cools off, I'll hit it with the wire wheel and then see how good it is. Okay, I got it cleaned up. The point of it anyways, and it's pretty hard. I mean, it's not like it's glass hard or anything, but the file is skating across it pretty good. It's not marking it up near the tip. Back here, I can feel the file digging in. but up at the point, it's pretty good. So that's how you case harden. This, I think I said in the beginning, this was alloy steel. And if it was, it would have hardened up a lot more. But this, I'm pretty sure by the way it was cutting, that this is mild steel. So, you know, adding carbon to it is going to make it harder. And it is harder. So, I'm going to clean up the rest of this. I'm going to set up the boring head and the tailstock, and I'm going to dial in a small taper on a piece of scrap and show you how that works. Okay, so I'm just going to turn a quick taper here to show you how this works. This boring head is level and it's on center, but horizontally, as you can see, it is not. So what I've done is I've moved it up here, and I'm going to center this thing. Okay, that looks pretty good to me. Okay, so that's centered, and what I'm going to do now is I've prepared a piece here. Zoom out. Okay, it's just a hunk of scrap. And what I'm going to do is I'm going to put this between centers with a dog on it. Now, I know the distance between these two, so I can calculate how much offset here I'm going to need to get the desired taper that I want. Okay, time for a little math here. So I know my piece is 8.5 inches long between centers, and that's just a convenient length I had on that piece of scrap. So the way you figure out how far the offset is you say you want to cut a 1/2 degree taper. Okay, so 1/2 degree. You take the sine of that, and then you multiply it times the length. So that's telling me that I got to set my offset 74 thousandths over from the center line of the lathe. So I'm going to do that. Hang on. Okay, so when I centered up this boring head, I ended up with 39 thousandths on the dial. And when you add in the 74 thousandths that I wanted on this thing, you end up with 113. So what you want to do here is rotate this around to 113. Okay, there's 0, so 13 more. Okay, and that's how you set the offset. Okay, so now what's going to happen is this workpiece is catty-cornered to the, actually it's this way, to the bed of the lathe, to the axis of the lathe. So when I turn this thing on and start feeding it, okay, I'm going to touch it off. Okay, and here comes some feed. Let's just make that a little finer. but you can see how it ran off. Okay, so I don't know if you can see, but that did cut a taper, and it's a pretty precise taper. On this end, it's 584, and on this end it's 619. By the math, that is a very precise half a degree taper. Now there are other ways to cut tapers too. You've seen me do them with the compound. There's another way to do it as well, and that's with a taper attachment or a tracer attachment, which I don't have either of those on this lathe. Guys like Fenner and Rucker and those guys with the higher end lathes have those attachments for them. But this method works for cutting long tapers. I mean, my tailstock isn't even, I could put another 6 inches on this easy, and if I took my chuck off and mounted the center in the headstock, I mean, what are you talking about? You could do 2 feet here. So that's how this boring head can offset the tailstock. Typically, if you didn't do this with the boring head, you would actually offset the tailstock. Let me show you here. This screw right here, and there's another one exactly on the other side. If I wanted to offset this tailstock, I would loosen these 2 screws, which clamp the gib, which is right here. And then I could adjust these, one pushing and one pulling, to move the tailstock off center. And people do that every day, but I don't like doing that, because to adjust the taper back out, you have to take a bunch of test cuts and measure the bar that you're cutting and see that the taper is out of there, and if not, you got to adjust this. And that can be a tedious process. I know a lot of people do not like to change the centering of their tailstock. So this just gives you a real convenient way of doing it accurately. You know, you don't need a dial indicator or anything like that. You just turn this knob. This is accurate here. Count how many thousandths you want and offset it. When you take it out, this thing's still on center. So that's what I did this for. Alright? Oh, and one other thing. Please be careful when you're running a lathe dog like this. If you get caught in this thing, you're going to be on YouTube as an industrial accident. So just be aware that when you're turning something with a dog, and yeah, this screw's long because this dog is a little big for the work, so I had to put a extra long bolt in here. But you know, just be real careful when you're using a dog like this, because I mean, you touch it and you're hooked on it. So that's my public service announcement for the day. Alright, we got another little shop project going here. This Dayton crane I've had for a long time, and I used to have this hook on the top of it, which hooked to an eye bolt on my doorway over here to the shop. But recently I picked up a pretty nice crane scale. So what I'm going to do is I'm going to make a little adapter, because this scale had this hook on it, and I didn't really like having two hooks together. So what I'm going to do is I'm going to make something that will hook this up to here, and then we'll hook a hook to this. We'll connect a hook to this thing, and then we'll be able to measure stuff. So got a piece chucked up here. What I'm going to do is I'm going to turn this down to a 1/2 inch for 3/4 of an inch, and then what I'm going to do is take it out of here and put it in the milling machine and mill flat on the top, and then drill a couple holes in it. So let's get going. Alright, get this thing mounted in square collet block. And I'm just going to take 300 thou off each side. Should leave me 400 in the middle. Okay, so here it is finished. And we got this collar that goes with it. So we'll install this in the top of the hoist right now. And as they say on the hydraulic press channel, here we go. Alright, 213 pounds. That's what the front end of my tractor weighs.